Hi everyone, hope you're having a great day today. We're going to go over chapter 11.3, which is over vectors and their applications. So first, let's find out what is a vector by identifying what is a scalar and some properties of vectors. First, we're going to talk about a scalar. A scalar is basically a magnitude. So a scalar is just a number. Whereas a vector has direction and magnitude. Okay. So a vector, we're going to use a line with an arrow on the end. And you can see here that normally when we use a vector, we also dictate the direction that we are going to go in. So normally I like to give this a name. So I'm going to call this part right here the tail and this arrow here the head. Let's see. Okay, so again, this here is the tail, and we call this one the head. Okay. And a lot of time, of course, we're going to use the value for the tail, and then another point somewhere around here for the head. Now, it doesn't matter where along this line is because this is like a ray. So a ray extends in one direction. So therefore, you can just pick any point on this ray. However, the tail has to be the first point that you start off with. So we call this vector here OP. Okay, so here they just use the value called initial and the terminal point. Okay, so the terminal point can be any values on here, any point on this ray, I mean. So you can see here, vector OP is not the same thing as vector PO because the direction is different. However, this here, you just see that they are the same magnitude but opposite directions. So therefore, we can say that vector OP is actually negative of vector PO. Okay, so the negative vector means that it has opposite directions. Okay, you can see here, negative in a vector means opposite direction. All right, some properties. Now, if I have two vectors, they are equal if and only if they both have the same magnitude and directions, which means that vectors do not have positions. So note. So what I mean by having position is that if you have the Cartesian plane, let's say I have this vector right here, and I have another vector somewhere down here. Okay, you can see they both have the same magnitude and they both point in the same direction. Therefore, we say these two are the same vector because they have the same magnitude and direction. Okay, so we talk about standard form of an angle. Well, we also have a standard form of a vector. So a standard form means that the initial point or the tail of the vector will move to the origin. Okay. So the standard form of a vector is going to be the initial point, or I call that the tail, is starting at the origin. Okay, so I can move this vector right here to here. Okay, now it's in standard position. Okay, so let's say this is in standard position. So once it's in standard position, we can actually determine the angle of the vector and also the magnitude of that vector. See how long it actually is by just using Pythagorean theorem, because you can see here it creates a right triangle. All right, so now we're going to talk about how to find the sum of two vectors A and B. So to find the sum of the two vectors, line up the tail of one vector to the head of the other vector. So here they're using the same terminology by using terminal point and initial point. So basically put the initial point to the terminal point of the other vector. So let's look at this. Here you have angle vector A and vector B. So here we take the tail or the initial point of vector B and we put it at the terminal point of vector A, or the head of vector A, where they meet. So here, basically at this position right here, we have a vertices for this triangle. So we can create the sum by taking the initial point of A to the terminal point of B to create this triangle. Now, this parallelogram rule means that it doesn't matter if you put the tail of B to A or if you take the tail of A to B, which is what we're doing here. Here is A, and we are taking the tail of A, okay, to the head of B to create this triangle over here. And because this is a parallelogram, this side is equal to this side is equal to this side, but you see that they both share the diagonal, which is the resultant vector, which is the sum of these two. So it doesn't matter the order that you add these two vectors in. You will always get the same magnitude and direction, which is A plus B. All right, so what I just explained was vectors are commutative. So if we take A plus B first, it's the same thing as if you take B plus A. And the sum of it is called the resultant of A and B. So resultant is the result when you add A and B. Now for every vector, there's going to be a zero vector. Zero vector just means exactly that. It basically has a length of 0 or magnitude of 0. And we can see that if I have two vectors that are opposite of each other, so let's say one vector go this direction, the other vector go this direction, but they are exactly the same magnitude, if you add them together, you get the zero vector. Okay, so a scalar product, scalar just means a real number, so you're going to multiply it by stretching it. So what this does is it's going to stretch the vector by whatever magnitude that number is. For example, let's say this is the magnitude that has a length of 1. Okay, so let's call this vector here vector u. If I want to lengthen this, so if I take 2 times the vector u, it's going to make my new vector twice as long as this one. So let's say this one right here. So this is 2 times vector u, which here you see the direction is still the same. The only thing that's different is that the magnitude or the length of this vector is now double the original. Okay, so that's what the scalar product means. Now, if you want to multiply by a negative number, for example, if I want to take -2 times u, so this is my vector u, I'm going to multiply -2, which will change the direction. So now this is -2 times vector u. Now the length is still the same, only the direction changed. Now it is opposite of our other vector. Okay, so again, negative vector is the opposite direction. Okay, so here we're going to use a position vector. Basically, that is in standard form. Okay, so position vector means the same thing as standard form of a vector. So you can see here the initial point is at the origin, which is what I described earlier. So I told you that position vectors do not have positions. Now, if we put it in standard form, then we have the initial point at the origin, and then point out to whatever quadrant it is. All right, so a position vector u with endpoint AB. So the endpoint AB tell us where it is pointing and also tell us the magnitude. So this point right here is point AB. Also, we can use the component form in order to write the vector. Okay, so for example, here this is point AB, but if I want to write u as a vector, I'm going to use this component form, and we use these ankle braces here, bracket, I guess, in order to determine what is the location in standard form or in position form of the vector. For example, if I want to call vector u 2, 3, now I'm going to plot 2, 3, and that would be my end position of my vector. We're going to connect that to the origin. Now this is vector u. Okay. Now from there, we can find out what is the magnitude of this vector, because I know the x is 2, the y is 3, so therefore the value for this magnitude would be 2 squared plus 3 squared square root, which is just the Pythagorean theorem. So that's 9 plus 4, which is square root of 13. So now this vector has a magnitude of square root of 13. And here's exactly the formula for that. Now you see here that the magnitude is always positive, so therefore we always have to take the absolute value of it. Okay, so note. Now the notation for it, now this here looks like absolute value symbol, but it's not. It's actually the symbol for magnitude. So a lot of time other books uses the double bar for this. Some books get lazy and they use single bar, okay? But it means magnitude. So this means magnitude of u. Okay? Now you can think of it as absolute value because the magnitude is always positive. The negative tells you direction, okay? So the direction angle says 5. So if you look at an angle in standard position, okay, if I know that this is B or A, okay, so this is the point XY or AB, okay, then the magnitude U is equals to A squared plus B squared, the square root, which you see here. And the angle theta, we can use opposite over adjacent, which is tangent. So tangent theta is equals to b over a, which they got here. Okay, so let's find the magnitude and direction angle for u, which is at 3, -2. So anytime you see this, this is in standard position, so you know the initial point is going to be at the origin. So if we plot it just to have an idea of what it looks like, you can see here that this is the point 3, -2. Then we draw our vector from the origin to this point 3, -2. So the angle that we're interested in is actually in standard position here. Now, we're not going to be able to get that by applying tangent, because tangent inverse is only exists in quadrant 1 and quadrant 4. Okay, so to find the angle, we use tangent of y over x. So y here is -2, x here is 3. Now, it's going to give us -33.7 because, again, tangent inverse only exists in the first and fourth quadrant, and you can see here this is definitely in the fourth quadrant. But we need to be able to get the positive angle. So here they give us -33.7 degree, which is this value right here, going clockwise. Now we want it in standard position, which is the positive smallest angle that will satisfy the same terminal sides. So all we have to do is just add 360 to it, and we will get 326.3 degree, which is this angle here. Okay. All right, so to find the magnitude, very easy, because all we have to do is just take the Pythagorean theorem, and we saw that earlier. We saw that was square root of 13. Okay. Any question, Mohammed? Am I going too fast, or are we good?
Yeah.
Okay. All right, so now we're going to talk about the component form, the horizontal and the vertical component. So basically, what this means is we're going to look at that triangle that was created, like here. So here, let's say this is my vector u. Okay, so the vector u can be made up of components, which is the sum of the x component plus the y component. So the way we write this is that we use a subscript u of x, that's the component of u, but the x form, and the y component of u. So if we want to know what the value of the x and y component is, so let's look. So let's say that this point right here is AB. Now you see the horizontal component here is always going to be a horizontal line. Now if we take the x component plus the y component, you can see here that it gives us the vector u. Because if I take the red one plus the green one, I'm going to get the blue one using vectors addition. Sorry, I have to blow my nose there. Okay, so let's look at the component form. We know from the unit circle before that the point xy equals to cosine theta and sine theta. Well, if you look now, you see that the x component is basically the x value, and the y component is the y value. So therefore, they use the magnitude, which is basically r cosine theta and r sine theta. Okay. So this r here is basically the radius of our circle, while the radius was basically the magnitude of the vector. So this is why the magnitude of u times cosine and the magnitude of u times sine will give me the component form of each of the vector. So let me make sense of this and connect all this together. So this formula right here deals with the unit circle, right, where my radius is 1, right? So any x and y here can be determined by using the angle. So this point xy right here can be found by using theta, by using cosine theta and sine theta. Now here, this u does not have to be 1, but if it is 1, then we just have point AB equals to cosine theta sine theta, okay, if the magnitude of u is 1. But we're not dealing with the magnitude of u of 1, so therefore we have to add in the magnitude of u, cosine theta, magnitude of u, sine theta. So this is a general form for any magnitude of u, okay? So this is the same thing as if I'm saying, if I have a bigger circle, which have a different radius, so r is not 1, so r is whatever number, any positive number, you can see here that this point xy will become r cosine theta and r sine theta, because now we basically just stretch this circle by a factor of r, okay? All right, so this is another formula that you will need to memorize. And I don't like the way that they use the single bar. I'm going to use a double bar to represent magnitude. Okay, so let's try to find out what is vector W and find the horizontal and the vertical components of this vector. So here they give us the magnitude, which is the length of this triangle, which is 25. And they give us the angle, which is 41.7. Now, the magnitude of A and the magnitude of B can be found by using the formula that we just got. Okay. So if we use the formula that we just found, so we have the component form of U, component form of, horizontal component and the vertical component. We can take the magnitude, oh, this is W, right? I'm sorry. So we take the magnitude of W times cosine theta and the magnitude of W times sine of theta. So the magnitude can be found, it was given here, magnitude is 25, and the direction is 41.7, so cosine of 41.7. Okay, and so it looks like 18.7. So what does this 18.7 represent? Well, 18.7 is the magnitude of this component vector. So this is 18.7, and this here is 16.6. Okay, so now if you use Pythagorean theorem, 18.7 square plus 16.6 square is going to equal to 25. Okay, so that basically just ties everything together here. Okay, write each vectors in the figure of the form AB. So now form AB is basically just the endpoint of my vector. You can see here they give us the following. Okay, so here they give us vector U has a magnitude of 5. Oops. magnitude of u is equal to 5, and theta is 60 degrees. And we have v, magnitude is 2, and theta is 180. Magnitude of w is equal to 280. Oops, that's not 86. And the angle is 280 degrees. Okay, so that's all the information they gave us. Now, I'd like you guys to see if you can find what is the form AB for each one of these vectors. So remember the formula. A is equals to the magnitude of whatever vector times cosine theta. B is the magnitude of sine theta. Okay, go ahead and take some time to figure that out. Let me know if you need help. Okay, so let's look. All right, so to find the vectored form AB, we just have to use the magnitude times the cosine of theta, and theta here is 60. So cosine of 60 is 1/2. So we just have 5 times 1/2. We get 5/2. Same thing, we just take the magnitude 5 times sine of square root 3/2. Okay? All right, so for V, well, this one's a little bit easier because this one actually falls on the x-axis. So you don't have to really do anything fancy here because the point just fall on the x-axis and it has a magnitude of 2. So the point is -2, 0. But of course, if you use the formula, you arrive at the same answer. Now the third one is a little bit, you have to be a little bit more careful, okay? So here, theta is 280 degrees, which is in the 4th quadrant, okay? So if we look at cosine, it's going to be positive, but sine is going to be negative. Now, when you type in your calculator, okay, you're going to have sine of 280 degrees. It's going to give you a value. Let me see. I'm going to type it in. Give me a second. And make sure that your calculator is in degree mode. And let's type in sine of 280 degrees. It's going to give you negative 0.984. Okay, what does that mean? Okay, negative 0.984. So that's the value for it in the fourth quadrant. So remember, the sign is going to go at it's going to be negative in the fourth quadrant. So if you take that, multiply with 6, it's going to give you negative 5.9. And then for cosine of 280 degree, you're going to get a positive number. And you're going to get 0.7173. Multiply that with 1. I'm sorry, multiply that with 6, and you get 1.0419. Okay? Oops. Uh-oh. What happened? I lost my whiteboard. Okay, so let's talk about properties of parallelograms. Now, this is important for you to be able to understand how to solve for word problems later on, because you will need to use parallelograms in order to solve the word problems. So what is a parallelogram? So when we have a parallelogram, it has two parallel sides, two parallel sides. So this side and this side is equal, and they're also parallel to each other. This side and this side is equal and is also parallel to each other. Okay, so the opposite sides are the same. So this side and this side are the same, and this side and this, I'm sorry, angle, and this angle is the same. So let's call this an angle A and angle B here. So angle A plus angle B will equals to 180 degree. Okay, this means that they are supplementary. Okay, now the diagonal do not necessarily bisect each other. So the diagonal mean. So diagonal from one corner to another. Okay, here they do not bisect the angle, but they do bisect the sides. So this one is the same thing as this one. This one is the same thing as this one. Okay. So we're going to use this fact later on. So make sure that you touch up with this if you don't remember what this is. All right, here we go. So this is where it gets a little bit hard when we deal with vectors in word problems. So the concept is not hard, but when you apply it to actual word problems, it gets kind of difficult. Okay, so we normally use vectors to denote a force. So a force is like something pushing or pulling, or like a wire hanging. So that's all different type of force. And we measure force in terms of Newton. Okay, so two forces of 15 and 22 Newton act on a point in the plane. If the angle between the forces is 100, find the magnitude of the resulting force. Okay, so let's look at how we can sketch this. Okay, so the only thing we know so far is that we have two forces, 15 Newton and 22 Newton. Is it 22? Yep. And the angle between the force is 100. All right, so let's say one of the vector is here and the other one is somewhere here. So this one will be 15 and this one will be 22. And the angle between them is 100. Okay. Now, what is the resultant force? So in order to determine resultant force, remember that when we have to add them, we have to put the tail of one to the head of the other one. So I have to move this vector right here and line up with the tail, with the head of the other vector. So now basically this side and this side is the same. Okay, this is also 22. So now I can find out the resultant force, which is from the tail of one to the head of the other, and that would be my resultant force. Now I can do the same thing by moving this side over here, and you can see we end up at the same spot. Okay, so now we have what's called a parallelogram. So this is also 15. So what we're interested in is what is the resultant force, so which is this green diagonal right here. Okay. All right. So what we can do is, you notice we have a triangle, 15, 22, and this one right here is not the angle for this triangle, so we need to find another one. Well, the nice thing about this is that since we know that this angle and this angle are supplementary, that means that I know this angle here has to be 80. So now let's redraw this triangle and make it a little bit neater. And we can label everything. So I know now this is 80, this is 15, this is 22. What we are given now, this is a side angle side triangle. If I know this is a side angle side triangle, I can easily find out what is the missing side here. Okay, using what? Anybody? What can we use to solve a side angle side, Mai? We use law of cosine. All right, so remember law of cosine is basically the square of each of the side. So 15 square plus 22 square minus 2 times each one of these side, cosine of 80 degrees. Okay, so if you enter all that and then take the square root, we have x is equal to, let's see what they got. About 24 newtons. Okay, so that means that my side here is 24. Okay. So basically, most of these problems, if you are able to draw the parallelograms so you can figure out the angle so that we have a side angle side triangle, then the rest of it would be very easy. Okay, so now we're going to look at how to add and subtract vectors using this notation. All right, so if you want to add the two vectors together, just add their components. So for example, if I have vector u equals 3, -5, and vector v 7, 2. So if I want to find the resultant of u plus v, all you have to do is add straight down. Okay, so I'm like 3 plus 7, I get 10, negative 5 plus 2, I get negative 3. That's it. That's how you add vectors. Very easy. So this here is a scalar multiplication. So basically, if you want to stretch the vector by however unit, all you have to do is distribute whatever that scalar value is. So you get k times a and k times b. So for example, if I want to do 2u, so I'm just going to take 2 times 3, negative 5, and so I get 6, negative 10. So let's look at what these vectors look like when I try to graph it. All right, so 3, negative 5 is here. So you see it's in the fourth quadrant. Now, if I want to take twice of vector u, it's 6, 10. So that's 3, 4, 5, 6, 6, 7, 8, 9, 10. So basically, it's just the same vector, but now it has twice the magnitude or twice the length. So this is 2u. Okay. What happens if I do negative u? Well, this is just a negative 1. So this becomes negative 3, 5. So where's negative 3, 5? 1, 2, 3, 1, 2, 3, 4, 5. It's just the opposite direction of vector u. So this is negative u. So you can see here it's the same length as u, but it's just in opposite direction. Okay. All right, so here, if you want to subtract two vectors together, then all you have to do is just distribute the negative and then just add them. So you can just subtract just like you normally do. Okay, so I want to do vector u minus vector v, so you just subtract these two. So 3 minus 7, negative 5 minus 2. So I get negative 4 and negative 7. Okay. Okay, so I'm going to give you some time to try this. Are you guys in the whiteboard? Let's come in the whiteboard and do the problems. Okay, let's do the problem to the left of this. So there's some space over here you can use. Are you guys writing? I don't see anybody. Mike, why don't you do A, Terry do B, Mohammed do C. do A here, B, C. All right, very good. So let's check our progress here. You have 2, 4. Very good. So for part B, you see here, all we have to do is multiply -2 with u. And you can see that after multiplying by a negative number, it changes the direction. And the 2 stretches that vector by 2. So now it's twice as long as the original vector u. And then for part C, which is going to multiply 3 with u and -2 to v, and then add them together. So we got -14 and -3. Looks like you missed that one, Mohammed. Oh, you're only doing the first one. Okay, you haven't done the second part yet. Yeah, so -63 is the first one, and then 86 is the second one. Or you can actually multiply the -2 instead of the +2 like they did here. And then add them together. So -14 and -3. Okay, so moving on, we need to talk about unit vector. Unit vector, just like the name, unit means one, like unit circle, right? So unit vector have a magnitude of 1. Now, we use this a lot in physics. We're not going to touch this as much in here, but it's useful that you get an understanding of it so that you have exposure to it before you go into physics. So vector I have a magnitude of 1, so you can see here, it's just 1, 0. And it basically is the x-coordinate. J is the y-coordinate. So what this means is that if I want to extend this vector, I just have to multiply by a scalar value. So if I want, for example, this vector right here, this is just 4i because I'm multiplying a scalar of 4 times I. So using this notation, I can basically write any vector I want. For example, let's say I want to write this vector here. Let's call that one u. So I can do my x component 4i plus my y component. And my y component here is 4j. So if I do 4i plus 4j, that is going to be the definition of vector u. Okay, so this is just another way of writing vector u as 4, 4. So these two means the same thing. Okay, this is called unit vector form, and this is just called the standard form that we use for vector. Okay, so let's see here. You can see that I just demonstrate why this is equals to this. Okay. All right, so the dot product. Dot product is a little bit confusing. So you can think of dot product as multiplying two vectors. But the thing about this is that if you add two vector, let me type this in there. If you add or subtract two vectors, then the result is another vector. However, if you multiply or apply the dot product, get a scalar value. So scalar just means that it's just a number with no direction. Remember that a vector has direction. Scalar is just a number, it does not have direction. All right, so how do we do the dot product? Well, dot product, if you have vector u, which is AB, and vector v, which is CD, all you have to do is multiply the respective value and then add them together. So this is why you can think of it as multiplication, but it's not really multiplication. So here, if I have u equals AB, v equals CD, and we just multiply these two, add it to this two. Okay, so we get AC plus BD. times d. Okay, so that's u dot v. Now, what does the dot product give us? Well, the dot actually give us the angle between the two vectors. And we're going to demonstrate that later on. Okay, so to find the dot product of each, all you have to do is multiply its respective numbers. So here we have 2 times 4 plus 3 times -1. So we get 5. So you see here, this is a scalar value. This is not a vector. Okay. Now, here, the same thing. You want to multiply I with I and j with j, and then sum them together. So 6 times -2 and 4 times 3. Now here we get 0. Well, what does that mean? If the dot product equals to 0. Well, we're going to see what that means in a second when we introduce another formula. All right, so here's the properties of the dot product. So the dot product is commutative. So if you do u times v, u dot v, you're going to get v dot u. It is distributive, so you can take this and distribute. And of course, it works the other way around as well. Now, this is scalar product, so you can multiply the scalar first. This is an associative property. Or you can just multiply, take the dot product of the two first. Okay, and you can switch them all the way around. This is the identity value, so the zero dot product property. If you take 0 vector, multiply with a u vector, then you get 0. And here, if you take 2 of the same vector, multiply them together, this here is the magnitude. You get the magnitude square. Okay. All right, so let's talk about the angle between them. Now, if theta is the angle between the two non-zero vector, u and v, where the angle is between 0 and 180, then we have the following formula. Cosine of theta is equal to u dot v over the magnitude, let's use the double bar, the magnitude of v times the magnitude of u. So I would suggest you memorize this formula and not this one. This is just a definition of u dot v, but we use this formula to determine the angle between the two vectors. So this is where that comes in. All right, so let's sketch this out. Now, I want you to practice sketching A and B out, and then we're going to basically review everything that we've learned. All right, so I want you to sketch vector A, part A, and Mohammed sketch part B. So let me see if I can find some graph for you here. Okay, well, probably easier to just sketch it by hand. Okay, Mom and I want you to sketch U and V in standard form. Okay, go ahead. Mohammed, you here? Did you say something, guys?
Yeah, I'm here.
Okay. Go ahead and start sketching it. It's not hard. Just sketch the vector 2, -6. Plot it and then draw it. Ma, you here?
Yes.
Okay, start drawing. What's the problem, guys? Do you not know how to draw this? Hello? Oh boy, okay. Let me just show you the result. Okay, so what I wanted to show you is that we want to have an understanding of what is the angle between these two that when you create them. So when we have, let's see, 3, 4, that's our first vector, u, and then we have 2, 1. Now we can find out the angle, which is theta, in between these two. So when we do this, by using the formula here, using the dot product divided by the magnitude of each. So we need to know the magnitude of each vector, and we can do that just using the Pythagorean theorem. And then the dot product be the numerator. And so when we take cosine inverse to find theta, we have the angle which is about 26.57 degrees. So that looks to be pretty reasonable here. So you can see once we have this, we can have psi angle psi, because this will give us the magnitude of u. So 5 square root of 5. This one right here would be square root of 5. Now I will have psi angle psi. Okay. Now I can find out what is the triangle here. So if I want to find out the sum of these two, then you got to take this and move it up to here in order to determine our magnitude. Okay. But once you find this angle, you can find out the other angle as well. All right, for part B. All right, so we see here that the dot product is equal to 0. So what does that mean? When I take cosine inverse of 0, I get 90 degrees. So we make the conclusion that if the dot product between two vectors is 0, then the two vectors are orthogonal. Now, this is a new word if you haven't heard of it before. Orthogonal just means perpendicular. Okay, that means that they are 90 degrees to each other. So if one vector go this way, the other vector go this way. And so they create a 90 degree. Okay, so this is where they would intersect. And so I'm sure they'll give you that next. Here we go. So here is the angle between the two. So if you have the dot product is 0, you're going to have a right angle. If your dot product is positive, you're going to have acute. If it's negative, you're going to have obtuse angle. So memorize this one right here. Okay, I wouldn't bother with this part because this you already know from last time. Because if it gives you the cosine between 0 and 2 and pi, so this one would be the first quadrant. This is 90 degrees. This is our second quadrant. All right. So here is the hard part, finally. So a lot of your exam question will be some form of word problems such as this. Now, I say a lot, but maybe like 3 or 4, because you have to be able to sketch this and be able to understand bearing and be able to understand how to create a triangle from vectors. Or we're also going to talk about force later on and be able to sketch out the resultant force. So I think the sketching is probably the most difficult part of this exam, because if you're unable to sketch this, then you will not be able to find out the angle. All right, so let's practice sketching something like this and see if you're able to sketch the right thing. Okay, so Mohammed and Mai, please go ahead and do it here. Just sketch this. Okay, so go ahead and read the problem. I just want to see you guys try to sketch this. It's okay if you don't get it right because we're still practicing here. Let me know if you have difficulties in order to do anything here so I can maybe help you. Mai, Mohammed, are you doing on paper first or what? Okay, stay silent. All right, anyway, I'm just gonna do it. You guys have a 0 for participation. All right, ship leave port on a bearing of 28. So anytime you see the word bearing, we are measuring it due north. So let's say the port is right here. It's going to leave the port and move in a 28-degree direction. So from here to here is 28 degree. And it travels for 8.2 miles. And it's going to stop here. Then the ship turns due east. Okay, so right here, you can draw the east. So it's going to go this direction for 4.3 miles. Okay, and it's going to stop here. How far is a ship from port? So now we want to know this distance. So this is our x here. Okay, and what is its bearing from the port? Okay, so what we want to know is basically the angle from this port here. Okay. All right, so first we need to find out what is this angle right here. Because if we have that, then we would have psi, angle, psi. Once we have psi, angle, psi, we can figure out what this is equal to. All right, so let's first thing is to try to draw that parallelogram because it's going to help us determine what is the angle of that missing, this angle is. All right, so we're going to extend this. So this and this is the same. And then copy this angle, this side over here, so that we have a parallelogram. So now we have this parallelogram. We will be able to identify what is this angle by looking at this angle. Now you see here, the only thing that was given to us is this 28 degree. Now this is 28. That means that I can determine what this angle is by taking 90 minus 28. Okay, so therefore I know this is 62 degrees. So if this is 62 degree, I can find out the measurement of this angle because they are supplementary. So I can take 180 degree minus 62. So I'm going to get 118 degrees. Okay. Now we can redraw this so that we have a nice little triangle. Oh, well, down here. So we can have a nice triangle. So I know this distance right here is 8.2. I know this is 4.3, and I just found this to be 118 degrees. And this is our missing values here. So we want to find out what x is, and we're going to use the law of cosine. So x squared is equals to each one of the side squares, since we have a side angle side triangle. 8.2 squared plus 4.3 squared minus 2 times 8.2 times 4.3, and then cosine 118 degrees. All right, so plug all that into your calculator and then take the square root of it. See what they get here. Mm, 10.9. And this is in terms of miles? Yes. Right, so my x here is 10.9 miles. All right, next, they asked us what is its bearing from the port. So what they want us to know is basically what is this angle right here. Now, in order to find that angle, I need to find out what this angle here of the triangle is. Well, we can do that easily because we can have the law of sine. So use law of sine. So this is our missing angle, theta, but I have a ratio, which is 118 and 10.9 miles that I can use. So I can use that ratio in order to find out my missing angle theta. So sine of theta is over 4.3, because that's the opposite side, equal to sine of 118 degrees divided by 10.9. And then, of course, we can solve for theta by multiplying 4.3 up and taking sine inverse of the whole thing. All right, so that would give me this angle theta here. Okay, but don't forget, we need to find out from due north. So now we have to add that extra 28 in there. So plug this into your calculator, and you should get about 20 degrees. And then we have to add that 28 in there to get a 48 degrees. So this angle theta here was 20 degrees. Let me make this cleaner here. So that I have this angle here is 20 degrees. We're looking for the bearing, so from here to here, and we have to add that 28, so that gives us 48 degrees. So it is 48 degree bearing from the port. All right, so now this is the hardest concept here. We'll talk about airspeed and ground speed. All right, so if you have you ever seen the video of a bird flying in a wind tunnel? So what they do is they actually have a very large fan, so they're blowing it at this bird, and the bird is flying, but it is not moving at all because the wind speed of the turbine matches the wind speed of the bird, which cancels out. So that means that to us, the bird is not actually moving at all. So that is called ground speed. So the speed relative to the ground, how fast is it traveling based upon the ground. Now the airspeed of the bird is 0 because the wind and the speed of the bird is in opposite direction. So therefore it cancels out. So it looks like the bird is not moving at all, and that it's airspeed. So if we consider this using an airplane, it's going to be, of course, you're not going to have an airplane that's going to push like a jet, so that it's not moving in the ground. It's not moving in the air at all. But there are instances that does happen for smaller airplanes. All right, so that is the difference between airspeed and ground speed. Now, um, for airspeed, it's going to change the direction of the plane by pushing on it. So let's look at what the airplane is looking at. So the pilot is going to set the bearing and the airspeed in one direction, but of course that's not always the case because the wind is going to push it in one direction or another, which is calculated using this vector. And so the final bearing and ground speed of the airplane, which is the actual direction the airplane is going, is the resultant force of the bearing and airspeed of the airplane and the wind pushing it. So the angle that is the difference between the two is called the drift angle. So that's how much the airplane drift due to the wind blowing at it. Okay, so now we have two vectors. One is of the airplane and the other one is of the wind. All right, so let's see if we can sketch this. So again, sketching this is the hardest part of the problem. I'm giving you time to try it, but you guys are not doing it, so I'm just going to skip over that. So you're going to have to go and learn this and practice this on your own. All right, a plane with an airspeed of 192 miles per hour is heading on a bearing of 121. Again, bearing is due north, okay? So 121 is going to be in the fourth quadrant because we are measuring due north. So this is 90, so 121 somewhere right here. So from here to here is 121 degrees. And airspeed of 192 miles per hour. And then a north wind is blowing from north to south. So anytime that you're seeing the word from, okay, from north to south, so it tells you that it's coming from the north, which means that the direction is going is actually the opposite from it. So it's actually going to the south. So you can see here is going downward, okay? So you're not going to get this little parentheses here every time. If they say from whatever, that means it's going to be in the opposite direction. That's where it's going to go. So from the north, so here's the north, but it's going to go down to the south at 15.9 miles per hour. And we want to know what is the actual speed of the airplane and its bearing. Okay, we can use that by looking at the drift angle as well. All right, so let's sketch this. All right, so let's label some stuff here. This is our drift angle. Okay, X here is the final speed or the ground speed. All right, so let's look at the component vectors of these two. You see here, the wind is blowing downward. Now, if you break this vector up, you can see that the component vector, one of them go east, one of them go south. So since one of them goes south and the wind is also blowing out south, that means it's going to help push the plane to go a little bit faster. Okay, so now if the wind was pushing in the opposite direction, that means it's actually going to slow down the plane because these two components right here are opposite of each other. So they're going to cancel some of the airplane speed, which means it's going to slow down. Okay, so now what we need is this angle right here so we can have psi angle psi. Well, the only information we know is 121 degree here. Now I'm going to give you a view of parallel lines and traversal, so you can use this fact in order to decipher this type of problem. So let's see here. If I have two parallel lines and I have a traversal, the following angles are congruent. This one and this one's the same. This one also. So 4 of those are the same, as well as 4 of these are also the same. Okay. Now they have different names like alternating interior or interior angles or vertical angles. It doesn't matter. You just have to know that these 4 green are the same, the 4 blue are the same. The reason why I tell you that is so that you can use this fact over here. Okay. All right. So if we try to break everything down here, okay, you see this line right here is my traversal. So I'm going to extend that so you can kind of see it. And you have the north and south line right here. Okay. So what you are given is this angle right here, which is the same as this angle right here. And look at that. That is the same thing as this angle. So this angle right here is actually 121 degrees. Okay. Now it's not going to be this easy every single time. Okay. This is probably the easiest example of this type of problem that you're going to get. Because the wind is blowing on one of the axes, like either north-south or west-east. Your test, you're not going to get that. It's going to blow at some random angle, okay? And we're going to see an example of that. All right, so in this example, we are solved that this is 121, so that makes it super easy. So now we can find x. So again, we're going to use the law of cosine. 192 squared plus 15.9 squared times 2, 192, 15.9. Cosine of 121 degrees. Type all that in and then take square root, and let's see what they got. And you can see the setup here. And x is about 200.7 miles per hour. All right, so let's see. We start off with 192 miles per hour. Okay, so that's the speed of the airplane. But the wind was able to push it an extra about 8 miles per hour. So we end up going a little bit faster. Now, this is the reason why when you're flying, you try to get into what's called either a headwind, which blows against the airplane, which helps you create lift, or tailwind, which pushes the airplane to go faster. So if you're traveling, you always want the tailwind to push you because it'll help you go faster. But when you land, you always want headwind, so that will provide you a lot more lift, so that you can land the airplane easier. All right, so now we want to find out the actual bearing of it. So we need to find out what is its drift angle. To do this, just use the law of sine, since we just found a ratio of the sine and the angle. So here, we need to find out the drift angle. That's called theta. Sine theta divided by 15.9 equals to sine of 200.7 divided by, what is our value here? Oops, no, that's not angle. Sorry. Sine of 121 over 200.7 miles per hour. Okay, so solve for theta. We have sine inverse of 15.9 times sine 121 divided by 200.7. And this angle is going to be very small because the wind is not going to alter it all that much, okay? So whatever this value is, theta, now make sure that you add the original angle, which is 121 here, to that drift angle to get the final bearing. So the actual bearing is going to be 121 plus theta. Let's see what this theta is. 3.89 degrees, or about 4 degrees. Okay, so that's not a lot, right? So our final one is 121 plus 4, or about 125 degrees. Okay. All right, so now we're going to get to the hard problem. Let's see. I think this is the last one, right? No, we have 2 more. Oh yeah, the force problem. Okay. Okay. I'm going to give you a minute just to absorb this. I need a break. Try to draw it out either on your paper or on whiteboard. If you do it on whiteboard, I can help you if you're stuck. Okay, so let's look at how to sketch this. Okay, so we have an airplane that's following a bearing of 239 degrees. And airspeed of 425 miles per hour. Encounter a wind blowing at 36 miles per hour from a direction of 115 degrees. Okay, so remember, the keyword here is from. Okay. Okay, so let's look. All right, 239 degrees, that's going to be over here. Now remember that we always measure from due north, rotating clockwise. So from here to here is already 180 degree, and going to here is going to be 270 degree. So it's somewhere going to be somewhere in here. So let's just say right here. And this is 425 miles per hour. And this is at 239 degrees. And then the wind is blowing at 115. Okay, so where's 115? Well, that's 90 right here. A little bit more would be 115. So again, I want to emphasize that it's saying from, so you need to go in the opposite directions. So the wind is actually going this direction. Okay, so from here to here is going to be 115 degrees. But since it's say from 115 degree, my actual vector I'm going to use is this one right here. Now, in order to get the magnitude, I need to move this over to here to create my parallelogram and to find out my resultant force. So my resultant vector is the blue one. Okay, so this is wind, and it is 36 miles per hour. Okay, so now I need to find what is this angle right here equals to. Let's call that theta, call this x. Okay, any questions so far on how to sketch this? No question? Man. No question at all. It's got everything. Were you able to draw this? Still no reply?
Is the drawing going to be always like clockwise?
Say that again?
I say, are we going to do it like always the clockwise?
Yes. So bearing is always measure clockwise due north. Okay. So we covered last time where if I say the word bearing, okay, you're always going to measure due north and rotate clockwise. Now, if it says, for example, like 150 degrees bearing. Now that's it's going to be different if you say, let's see, 40 degree north. Let's see, northeast. Okay, so that's going to be in the quadrant 1 because that's northeast. I don't know why I wrote west.
North, yeah.
Now, if I say 40 degree northwest, this is going to be in quadrant 2. Okay, so for the if they tell you the north or west side, then this one is going to be rotating in whatever quadrant it's in, due north. So 40 degree northwest is going to rotate this direction, counterclockwise. So this is 40 degrees. Okay, does that make sense?
Yeah, it does.
Okay, yeah, if it's if only say bearing without the north or the east or west or whatever, then it's always clockwise starting from due north.
Oh,
okay.
Okay.
Yeah. All right. So now here's the hard part. Can you please mute yourself? So the hard part is trying to find out what this angle is right here and what this angle is right here. Okay. All right. So now let's try to see to zoom into this figure here and figure out what is theta. It's not always obvious, and this is probably one of the hardest problems that you will encounter. So remember what I told you about the traversal and the parallelogram and the parallel figures. So if I draw my north, south, west, east figure here, this will give me an idea of what angle I'm dealing with. Okay, so if I extend this out here and extend this, all right. So the only angle I know is 115 and 239, right? So I should be able to figure out what this angle is here. Well, it is the sum of the two angles, which I need to find. let me get my marker here. It is the sum of this angle and the sum of this angle. Okay, so can I find out what is this angle here? Well, it is due north and here. Okay, so it's basically going to equal to this side right here. Okay, so this side, I'm sorry, not that one. This one right here. This one and this one are vertical angle. Okay, let me try to draw it again up here. It's kind of too cluttered now. All right, so this line right here is the traversal for the magnitude of the airplane, which is the green one right here. Okay, so this is the due north and south here. So this is the north line, south, and this is the magnitude of that airplane. So this angle that we're looking for right here, which is this angle, is the same as this angle right here. And this angle is this one right here. Okay, but that angle is the same thing as this angle right here. And I know what that angle is because what they give us was from here to here, okay, is 239 degrees. Okay, that means I can find out what this angle is right here by taking 239 minus 180 degrees. Okay, so that means this is 59 degrees. Does that make sense? So this is 59 degrees.
Why? Yeah.
Go ahead.
Yeah, I say why subtract 180?
Okay, so let me move this over here to show you. Okay. This here was the bearing of the airplane, right? And that was given 239 degrees. So from here to here is 239 degrees. I want to know what this angle is right here because it's the same thing as this angle right here. So I subtract 180 degrees because the distance from here to here is 180 degrees. I'm taking the difference between the blue one minus the green one, I get the red one. Because the green one plus the red one equals the blue one. Yeah?
Yeah, I got it.
You got it? Okay.
Yeah.
Great. All right, so that's only the first part. Okay, so I found out that was 59 degrees. So this portion right here is 59 degrees. Now I need to find out what is this portion right here equals to. Well, I can also find that fairly easily because I know this is 115 degrees here. So let me redraw this portion right here. Let's see. Okay. Let me do some more. One more. Okay. So this was the wind. And of course, I transfer that vector down to here so I can find the resultant vector. So the angle that I want is this angle right here. Okay. Which happens to be the same as this vector up here. Now, what is given to me? The part that was given is that the bearing of the wind blowing was from here to here. That was 115 degrees. Okay. Now, if I know from here to here is 180 degrees, and then I can find out what is this angle equal to, which is 180 degrees minus 115 degrees. Okay. So that's 65. That means this is 65. Now I can add these two together to find out this angle here. So 65 plus 59, 124. So now I got my angle. Now I can draw my triangle to finish the problem. Right, so the vector of the airplane is 425 miles per hour. The wind is 36. I just found this angle was 124 degree. Now I need to know the resultant vector here. So x squared equals 2, 36 squared plus 425 squared minus 2 times 36, 425 cosine of 124 degrees. And what do they have here? Uh, 446. Okay. So here's the better picture and not so messy. All right. So we need to know this angle right here. Let me reiterate everything here for you. We need to know this angle. To get that angle, we need to know this angle and this angle. Well, this angle right here is the same thing as this angle here, right? Since I know this is 239, I can subtract 180, which is the distance from here to here, to get 59 degrees, right? Over here, I know that from here to here is 115 degree. I can subtract that from I subtract 90 to get 25, and 25 is here, and then I get this angle here, okay? Or I can just do the same thing I did before, take 180, subtract 115 to get this angle here. So there's more than one way to do it, okay? All right, we have to find out what is the drift angle, which is alpha. So to do that, we use the law of sine, and that's the same thing that we've been doing before. You have sine alpha over 36, which is the side opposite from alpha, equals to the ratio that we just found, sine 124 over 446, and we found out alpha is about 4. And now in this time, we are adding 4 because it's pushing us this direction. So we have 239 plus 4 give us 243. Now your question is, do I always add the drift angle? No, you do not. Sometimes if the wind goes in the opposite direction, you may have to subtract the angle. It's not always adding the drift angle. Really depends on your figure. Okay, so you have to be able to sketch this out. Okay, we'll probably have to practice more next time. So make sure you do your homework so that you understand how to do this. If you don't understand, come back next time. And we'll do some more practice problem at the beginning of class. All right, that brings us to our last problem, which is required force. And I need to explain what is a normal force first. So anytime that you are dealing with an object moving at an incline, or basically moving at any angle, I'm just going to use a box here for simplicity. So let's say I have a box here. And so this box weighs whatever W is. Okay, so gravity always going to be affected on this straight down. Okay, so straight down is going to be gravity, the weight due to gravity. So that's W. And then what we have is called a normal force. So a normal force is a force perpendicular to the surface the object is on. Okay, so my normal force here goes down this way, where it is perpendicular, okay, to the surface. Oh, I think I wrote it down. It's supposed to be opposite. Opposite of the ground. Let's go this way. This way. Dang it. Perpendicular. There we go. All right. So you have another force in this direction. Basically, what the force is to keep the box from rolling down. Okay. So that really depends on how heavy the box is. So this is called F, and this one's called N for normal. So if these three forces are in equilibrium, the box, excuse me. So if all three forces are in equilibrium, which means they cancel each other out, then the object does not move. Okay, so let's think about this using a wagon here. So let's say you are pushing this wagon up a ramp at whatever angle it is. Okay, so think about it. If the wagon is heavy, it's going to require you more force to push it up, right? If the angle is steeper, it's going to require more force to move it up. Now, what happens if this wagon stays still? That means that you are applying the same amount of force as in the opposite direction, because the wagon wants to roll down the ramp, right, due to gravity. But you are applying a force the opposite of that, which prevents the wagon from moving backward. So that means that all three forces are counter-reacting with each other, which makes the wagon stay still. So when it stays still, we have this diagram here. Okay, so the way that they drew this is actually wrong. It's not supposed to be like this. This arrow right here is supposed to be in this direction. This is the normal force. Normal force is supposed to be perpendicular to the ground, so it's going up like this because the object is on top of it. So when I take the sum of these three vectors, okay, so let's look. How do we take the sum of vectors? We line them up, right? We take the head lined up to the tail, lined up to the head. So here they move in this triangle, right? So all three of them cancel each other out because they lined up perfectly like this, which means that all the forces, when you add them all together, equals to 0. That is the reason why this wagon actually stays still and not roll down or go up. Because if you don't apply enough force, then the wagon is going to roll backward. If you apply too much force to overcome the weight of the wagon on this ramp, it's going to move forward. Okay, so that's the fundamental behind this concept here. So now let's look at the values of the numbers. Here's a hint. Anytime you sketch this out, this is the relationship between these angles here. Okay. So I want to show you why this angle right here is going to equal to the angle of the ramp. Okay. All right, so if this is 20, this is 90 degrees, so that means this is 70. We also have this is perpendicular because it's a normal force, which means that this is 20 degrees. So the angle of the ramp is always going to be this angle here. Okay. Now, they're most likely going to ask you how much force is required to apply on this ramp, on this wagon, to keep the wagon from falling down or going up. Okay, so the weight of the wagon is always going to be straight down. So this 50 here would be the weight. We have the angle here, and then we have this that we need to find. So what is the magnitude of this force is equal to? Well, we can find that easily because we have a right triangle. So we can just use Pythagorean theorem or SOHCAHTOA in order to solve this. So here we use sine because sine of 20 is opposite, which is the force, over hypotenuse, which is the weight. So the force that we need is 50 times sine of 20 degree, or about 17 pounds. Okay. Now that should not be a surprise because here the wagon is 50 pounds, but you only need to apply less than half in order to keep it from moving down. Now, where is the other force being applied? Well, the other force is being canceled by the normal force, which is the perpendicular to the ground. So the wagon is pushing on this incline, and the incline is pushing back. That's the normal force. So some of it will get canceled. Because we are on an incline, that's why we don't need the full force in order to push this wagon, in order to keep it from falling down. So we only need about 17 pounds of force in order to keep the wagon from being stationary. Okay? Now, a lot of these force problem will imply that no friction is result here. So basically, we can assume there's no friction. But of course, there's always friction. If that's the case, we have to measure by the friction coefficient, which makes this problem much more complicated. So, yeah, and that's it. Any question? But you guys are going to stay quiet. So, have a good day. I will see you on Wednesday.
Have a good day. You too.
Bye, Terry.